Dr. Verdelli told you that we got this nice grant from the NIH for high impact innovation research, and the external reviewer, anonymous, wonderful, wonderful person in my opinion, said that our brain training exercises are easily the most sophisticated brain training programs ever created for anything. So with my very short presentations, I just leave it at that because we don't have time. But with you, I'd like to tell you about some of these functionalities that we created so that we could, that support this claim. I'm going to talk to you first about how do you decide when it's time to move a child from one type of cognitive demand to the other, one level of difficulty to another. Now, all the other brain training programs just do it on time. You spend a certain amount of time doing a certain one thing, and then you move to another one. Why do they do that? Well, one option is you can set a graduation criteria, right? That seems pretty obvious. Let's keep you on this until you reach this level. Now, if you're a teacher, you can work with a child and move that level up and down, right? You see what they're doing. They reach a certain level, you realize this is the best they can do now. You're not going to make them do the same thing over and over again. You're going to want to move them to some other type of cognitive challenge and task variation. So what happens if you try and automate this? You set a graduation criteria. If you set it too low, you won't challenge some kids. You set it too high, some kids will get stuck and never get to it. So it's a simple solution to that, but literally people haven't done it yet. The simple solution, you set a high graduation criteria. You monitor each child's improvement. And if they've reached a plateau for a long enough time and they're not improving, then you get moved up to the next type of cognitive challenge. And I can explain to you, let me give you some even more technical information. You appreciate this. You all know what adaptive tracking is, where you'll be making something harder or simpler every few seconds when you get something right. We do that. All the programs do that. But let's say you're training memory, and you're just a list learning test. So you get 3 items to remember in order. You make a mistake, it goes down to 2 items. Get it right, it goes up to 4 items. That's adaptive tracking. But in that adaptive tracking, what they're tracking here is list length. Is that the only thing related to memory? List length? It's not. How about study time? How about retention interval? How about similarity of the stimuli, the memoranda to each other? It's harder to remember a sequence of things if the stimuli are very similar than if they're very different. All of these are part of increasing memory more comprehensively. So if you're going to really design a training, and many of the memory programs don't even deal with that at all. But if you're going to do that, you've got 4 dimensions of difficulty. You're only adaptively tracking 1, list length. You have to know when's it time to move them to a different configuration. Say still 3 words in the list length, still a study time of 1 second per word, but now a retention interval of 5 seconds instead of 3 seconds. When are you going to make that demand? It's those sort of functionalities that you need this type of function of combining a plateau and a graduation criteria with. So that's one example. And what that does, you see, is it helps the program shape itself to each child's areas of strength and weakness. Because if you're very good at something, you're going to graduate through it quickly. If you're having trouble with it, we're going to keep you there, still practicing, not to the point of frustration, total frustration, some frustration, but we're going to then eventually move you on. So it automatically shapes itself to each child's profile of strengths and weaknesses. So if you have a classroom with 25 kids, you're getting 25 different lesson plans, not just because it's adaptive tracking of list length or one dimension, making it faster, slower, longer, shorter lists. We do that every few seconds, but also the type of task that they're actually going on is customized based on their individual progress and profiles of strengths and weaknesses. Now, we're also the only brain training program that captures every keystroke of every user, and you're going to see how valuable that information is. We built it in because I wanted to know how I could make our programs better. I designed them, I knew all the assumptions I made, and I really wanted to see how they were working so I could make them better. So we got to capture all that data. Then we said, wow, we've got all that data. We don't only want to know whether a child gets an individual response right or wrong. We want to figure out what type of mistake they're making. Real-time, online error diagnostics. Now with that information, you can give real-time, online corrective strategy messaging for an individual child, or build in performance aids based on that type of error that child's making, monitor their performance, and fade that out. These are all things that a good teacher would do, of course, but this we can build that in. So those are some of the functionalities that make our programs different from other ones. So we try and make the games fun. It's called mission cognition, and the children pick avatars and things like that. See a picture here of I mean, it's wonderful to see how intently, when they're focused, that they are, and they're working on these things.